Mmm. Tea. One of the reasons I make these videos in roughly 10-minute chunks is it's a nice chance to kind of get up and stretch. I have a 4-year-old son. When he can't pay attention, when things get to be too much, we stop what we're doing and we shake out the sillies. And not gonna lie to you, I'm not exactly preschool age anymore. It does help. So if it's a chance for you to get up, and that's great, something that we don't actually get to do in class. Although when we come back to live classes, I am thinking about incorporating shake up the sillies into my lectures. But we left off with cartography. So most people say geography is about maps, and as you're going to learn, maps are a part of geography, but they are not what geography is. Geography is the study of the world, and maps are how we communicate that. But cartography is actually how do you make maps. There is a science to it. Okay? So maps are great at communicating spatial information. And I always say, think about it. If you're having a party and you want people to come to your house, right? You could write down step-by-step turn directions, turn left on this street, but most of us will draw a quick little sketch. Come down this street, turn left here, right? If we're coming downtown and we want to know what train station to get off, we look at a map. It's a little bit easier to see where we're going. So maps are like pictures. They communicate spatially without words. And all maps reduce geographic space. If you had a life-size map of Chicago, how would you carry that with you? Because it is the city of Chicago. Right? Maps shrink space so we can look at things in a more manageable position. Now, think about that. If you shrink something, sometimes you lose the accuracy. The Earth is three-dimensional. It's a oblate spheroid, right? It's not perfectly flat, but maps are. Right here, I've got this link, and I'll make sure this is available to you also as well in the materials, that causes problems sometimes. So it causes distortion. And I'm going to pause this, and I'm going to open up this web page and show you what I mean. So don't go anywhere. All right, so I've opened up this web page. Again, the link is on the PowerPoint. It'll also be in the lecture material. It's called The True Size Of. This is a map of the world. Most of you are probably familiar with this. And this is a type of projection, which I'll explain what it is. This is a way of presenting a round map on a flat surface. But there's a problem with this. Most of you see this map, and you see this island here, Greenland. Now, Greenland looks to be huge. Compare Greenland here to Africa. What would you do? This is like the Matrix, right? What would you think if I told you that Greenland has the same amount of square miles as Mexico? Most of you are going to be like, how is that possible? It's huge. What this map does, and let's just do this. You type in the name of a country. There. So there's Greenland. I'm going to zoom out again. If I grab Greenland and I move it to where Mexico is, look what happens. It shrinks. It's like magic. Bring it back up north, it's the same thing. Bring it north, whoop, it shrinks. And I can't. Let's try this. How about I clear the map? What's happened if I type in Mexico? There's Mexico. Let's take Mexico for a trip. What happens? What is happening? This illustrates an issue with the map, the Mercator map. The Mercator map distorts the world, and I'll show you why. So let me pause the video and go back to the lecture. All right, so again, we're back. This is the Mercator projection, right? So here you can see better. Let me zoom in. You can see here you have your lines of latitude, right, north and south, and your lines of longitude. But there's an issue with this. This is what it looks like. You have straight lines north and south. But we know on a globe that all lines that run north and south, lines of longitude, they start at the pole, right? So they all meet at the poles. Does this line meet this line? It doesn't, does it? This is what they call a cylindrical projection. If you took an imaginary piece of paper, rolled it up in a cylinder, and then traced the continents underneath, you would get this unrolling and unroll it. And what happens is, because lines don't meet at the poles, the further north you get, these lines should be closer together, shouldn't they? Because they meet at the poles, right? And then go away and then meet back again. But because they don't meet, the further you go north, the lines diverge. And what happens is the land is stretched. Here's another example. These dots all represent the same amount of square miles. But you can see the further north you go, the larger they get, because these lines get stretched. You'll also notice that the lines that go east and west also get stretched. So why would you do this? Why would you do this on a map? Well, when you draw a map, you can never get everything perfect. You're going to have some distortions. And so it depends what you're mapping for. This map was designed for sailors. If you were going to sail from England to, say, Boston, right? You're sitting on the ocean. You need to know which direction to point your ship, what way to aim your compass. On this map, north and south is always 90 degrees. East and west is always 0. So you can measure that from here to here is 15 degrees southeast. And what happens is you'll follow that straight line and you'll get where you're going. If these lines met at the North Pole, right, they would kind of go into each other. That would mean that here, north would be this way. Here, north would be this way. So north would never be constant. And it'd be very hard to draw a straight line. Imagine if you had to draw a straight line on curved graph paper. It just can't be done. So for sailors who need direction to be accurate, this preserves direction. It does distort area. But if you're a sailor, you don't care how big the land is. You just want to get to a certain point. There are some maps that are called equal area. They preserve area, but they distort shape. So there's all different distortions. And projections are just ways of handling that. So go back to this map, right? You take these distortions. For a Mercator projection, it's just, it works for sailors. Now, the issue with Mercator projections is, a lot of people make the argument, if you look at this map, it exaggerates the size of the lands in the north, and it shrinks the size of the lands in the south. It makes your eyes focus right here for a lot of people because it's so much larger. And it shrinks how large these areas are. So if you are living in these areas, it almost, in a sense, can be diminishing. And this is an unconscious bias that a lot of people don't realize they have because of this map. If you show them other types of projections, I'll just show you this. Map projections. There's many different types. Here's a great one right here. These are all different projections, as you can see. Lagrange, here's a cylindrical projection. All these different ways of projecting it. They're all roughly the same, but they're all a little bit different, right? And you can see all these different ways of doing this. There's actually many different types of projections. All depends on what you're trying to project. So cartography is the science behind that. What type of projection are you going to use? How are you going to accomplish this? It's also how you can learn how to lie with maps. So different map projections use different ways to project. So what map, people ask, why isn't there one accurate map? It all depends on what you want to map. If you want to map area, you use one projection. If you want to map distance, you use another. All depends. But there is a definite art to map making as well. I mean, maps from the 1500s are beautiful. They're little hand-drawn cherubs that are blowing the clouds. Another thing we talk about in mapping is this idea of the Great Circle. A great circle is any line that goes around the world completely and makes two halves. So the equator is a great circle. That's at 0 degrees. You could go at different angles. Any line that makes a circle around the world is the great circle. If you drew a line from Chicago straight east and west that went around it, right, it wouldn't go around the thickest part of the world. That wouldn't be a great circle. But a great circle is interesting because a great circle, if you were to draw a line between any 2 points on Earth, So say Chicago and New York. And you draw that line on a globe, on a three-dimensional map from Chicago to New York. And you take that line and you continue past New York all the way back around to Chicago. That is a great circle. Okay? The part that would be from Chicago, let me get that line up here. The part that would be from Chicago to New York, that would be a small circle. A small circle is just part of a great circle. So let me show you what I mean. If you're going from Chicago to Tokyo, and you take a three-dimensional globe and draw a line, this is the straightest route. This is a small circle. If you continue that line all the way, that's a great circle. Now this looks kind of confusing. Why is it not a straight line? This is a projection that kind of squashes the globe because the globe is not quite this egg-shaped. So it accounts for it. Here's another example. If you're flying from New York to Spain, on a map, you would go this way. You think this is the straightest line. But this is our old friend the Mercator projection, right? It doesn't account for the fact that these lines get closer together, north and south. This is the shortest route. If you took a map, a flat map, and drew it, you get this line. And this is accurate as in direction. This is straight east and west. But the shortest mileage on a globe, if you actually put a string on a globe and pulled it tight, it looks curved. This is what it looks like on a globe. So you can see right here, that's a straight line. Even though this is straight east, this is the shortest line. So it looks kind of confusing sometimes. Not to worry too much, just let you know that it's out there. All right, I'm going to pause right here for another break, and we'll come back with our last section.